A new study has placed new size limits on how big that strange-looking interstellar asteroid Oumuamua is likely to be. The findings, reported in the Astronomical Journal, suggest the alien visitor is far brighter and consequently smaller than originally estimated, possibly as small as 100 meters or less. Back in November 2017, scientists pointed NASA's Spitzer Space Telescope towards the object in order to study it at infrared wavelengths. They found Oumuamua was too faint for Spitzer to detect when it looked more than 2 months after the object's closest approach to Earth in early September of that year. However, the non-detection puts new limits on how large the strange-shaped asteroid's likely to be. The study's lead author, Professor David Trilling from North Arizona University, says the very fact that Oumuamua was too small for Spitzer to detect is actually a very valuable result. He says Oumuamua has been full of surprises from day one, and scientists were eager to see what Spitzer might show. The new size limit follows observations earlier this year suggesting that outgassing could be responsible for slight variations in Oumuamua's speed and direction, which were detected as it was being tracked last year. The hypothesis being that the expelled gas is acting something like tiny thrusters, gently pushing the object in different directions and at different speeds. That determination was dependent on Oumuamua being relatively smaller than most typical solar system comets. Subsequent detailed observations conducted by multiple ground-based telescopes and NASA's Hubble Space Telescope detected the sunlight being reflected off Oumuamua's surface. Large variations in the object's brightness suggested that Oumuamua is highly elongated and probably less than a kilometre in its longest dimension. But Spitzer tracks asteroids and comets using the infrared energy or heat that they radiate, and that can provide more specific information about an object's size than optical observations of reflected sunlight alone could. You see, the fact that Oumuamua was too faint for Spitzer to detect sets limits on the object's overall surface area. However, because the non-detection can't be used to infer shape, the size limits were presented as what Oumuamua's diameter would be if it was spherical. Using 3 separate models to make slightly different assumptions about the object's composition, Spitzer's non-detection limited Oumuamua's spherical diameter to either 440 meters, 140 meters, or perhaps as little as 100 meters. The wide range of results stems from the assumptions about Oumuamua's composition, which influences how visible or faint it would appear to Spitzer were at a particular size. The new study also suggests that Oumuamua may be up to 10 times more reflective than the comets which reside in our solar system, and according to the paper's authors, that was a surprising result. Because infrared light is largely heat radiation produced by warm objects, it can be used to determine the temperature of a comet or asteroid. And in turn, that can then be used to determine the reflectivity of the object's surface, what astronomers call albedo. Just like a black t-shirt in sunlight heats up more quickly than a white one, an object with low reflectivity retains more heat than an object with high reflectivity. So a lower temperature means a higher albedo. Now, a comet's albedo can change throughout its lifetime. When a comet passes close to the Sun, its ices warm and sublimate into space as gas, in the process sweeping dust and dirt off the comet's surface and therefore revealing more reflective ice. But Oumuamua has been travelling through interstellar space for millions and millions of years, far from any star that could refresh its surface. But it may have had its surface refreshed through such outgassing when it made its extremely close approach to the Sun a little more than 5 weeks before it was discovered. In addition to sweeping away the dirt and dust, some of this released gas may have covered the surface of Oumuamua with a reflective coat of ice and snow. That's a phenomenon which has also been observed on comets in our solar system. Oumuamua is now almost as far from the Sun as Saturn's orbit, and it's speeding back into deep space well beyond the reach of our existing telescopes. First discovered on October the 19th, 2017, the strange-looking cigar-shaped object was originally catalogued as A2017U1, and then 1I 2017U1, and then later named Oumuamua, an Hawaiian word meaning a distant visitor arriving for the first time. It was initially detected by the University of Hawaii's Pan-STARRS 1 telescope as part of NASA's search for NEOs or near-Earth objects, celestial bodies which could pose a threat to our planet. At the time of its discovery, it was estimated to be about 400 meters long. This was later revised down to 180 meters by 30 meters in size. Oumuamua dropped into our solar system from the direction of the constellation Lyra, cruising through interstellar space at 25.5 kilometers per second. It approached our solar system from almost directly above the ecliptic, the orbital plane upon which the planets and most of the asteroids orbit the Sun.